Tonight's video is on section 4.4, the fundamental theorem of calculus. So this is day 1. Your homework from day 1 of section 4.4 is 1 through 4 all, 5 through 15 odd, 18, 19, 22, 23, 24, 25, 26. So let's begin. The fundamental theorem of calculus. It states that if f is continuous on the closed interval a through b, and capital F is the antiderivative of f on the closed interval a through b, then this function f of x, as we take the antiderivative from a to b, equals, here is the antiderivative, capital F of x, from b to a, equals f of b minus f of a. In other words, this is how you find area underneath a curve the calculus way instead of the geometric way. It's by the fundamental theorem of calculus. So you have your derivative, and you're taking the antiderivative from a to b. So once you go ahead and take the antiderivative, you're going to evaluate it from b to a. So f of b minus f of a. So let's do an example using the fundamental theorem of calculus. Here is the first example. Here is my function 3 from 2 to 7 of dx. So let's take the antiderivative of 3, that's 3 times x, and we're going to evaluate it from 2 to 7. So you put in 7 first, 3 times 7, and you subtract, and you put in 2 for x in the second one. So that would be 21 minus 6, which is 15. So this is the area underneath the curve. In fact, this is a pretty simple, straightforward one. I can go ahead and sketch this out. Let me do that right here. So this is the horizontal line, y equals 3. And then I have it at 2 and at 7 that I have to go ahead and I have to make these vertical lines. And so we're taking the area underneath this curve here, underneath my function. And so this is area equals length times width, which is 5 times 3, which is 15. So this is what it is geometrically. But what if it isn't so nice and neat? Of course I could do this one geometrically because it's so simple, but these are not always going to be simple. So I need to learn how to do it the calculus way, in other words, using algebra. So let's continue. Let's do another example. So I have my function, negative 3x plus 4, that's a line. So that's my curve. And I want to take the antiderivative. In other words, I want to find the area underneath this curve that's trapped by this curve, by the x-axis, by the vertical line x equals 5 and x equals 2. Well, instead of doing it geometrically, I'm going to go ahead and do it through calculus, or in other words, from doing algebra. So I'm going to take the antiderivative, negative 3x plus 4, that's 3x squared over 2, plus 4x, and I'm going to go from 2 to 5. So now what I'm going to do is I'm going to substitute in 5 for x, then subtract, and I'm going to put in 2 for x. So negative 3 times 5 squared all over 2, plus 4 times 5, I'm going to gather that up, that's with substituting with 5, subtract, now I'm going to substitute all over again by putting in the 2. Negative 3, quantities 2, quantity squared all over 2, plus 4, and again I'm evaluating it at 2. So now I have it all substituted in. Now it's time just to clean it up. So the 5 squared is a 25. I did the 4 times 5, which is 20. I'll make sure I'm going to keep this closed with parentheses because it's going to end up being a lot of algebra. I want to keep it straight. 2 squared is my 4, and 2 times 4 is 8. Let's simplify it a little bit further. So negative 3 times 25 is negative 75, still over 2, plus 20. minus, I better definitely keep this second one in parentheses because of the minus sign. So that's negative 3 times 4, that's a negative 12 divided by 2. That's how I got my negative 6, carry down my plus 8. Now 8 and a negative 6, that happens to be a positive 2. So I'm going to go ahead and write that minus positive 2. So now I'm going to go ahead and add my 20 and negative 2, which is positive 18. Now I'm going to go ahead and get common denominator of 2. That'd be 36 over 2. I'm going to add up the numerators. A negative 75 and a positive 36 is a negative 39 over 2. So that is the area underneath this function between 2 and 5 and trapped by the x-axis. So here is that problem graphed out to show it would not be that easy to do this one geometrically. Again, the equation was negative 3x plus 4. It's a line. The y-intercept is 4. And that the slope is negative 3. In fact, it's negative 3 over 1, and we want it from 2 to 5. So 1, 2, 3, 4, 5. So actually here, 2 to 5. So I'm here at 4, 1, 2, 3 over 1. 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 So I'm at 5, negative 11 here. So actually, here we go, from 2 to 5. And so this is negative area, and this is positive area. This is why we end up having an answer that is negative, because it's mostly underneath the curve. I'm sorry, underneath the x-axis, which is negative area. So I guess this one could have been doable. I accidentally had done to the 1. Could have been doable, but we are trying to now learn how to do it without drawing the pictures. Pictures are one way of doing it, but again, they don't always work out nice and neat. For example, this next one is a great example of that. Here I have a function, x minus 1 over x squared to the dx. I have no idea what that looks like graphed. And these values are correct. This is a larger value, and this is a smaller value from negative 2 to negative 1. So I'm going to go ahead and do this by the fundamental theorem of calculus instead of geometrically. So the first thing I'm going to do is I'm going to rewrite this so that I can go ahead and take the antiderivative. Now that I have it rewritten, it's ready for me to work it out. So take the antiderivative of x, that's x squared over 2, minus, I'm going to go ahead and take the negative 2 and increase it by 1, that's a negative 1, and then I write whatever that is underneath, and that is from negative 2 to negative 1. Now I'm going to go ahead and I'm going to clean this up, which is 1/2 x squared, negative and negative is positive, but that still goes in the denominator, so it's 1/2 x squared plus 1 over x, again from negative 2 to negative 1. Now I'm ready to go ahead and substitute a negative 1 for x, then subtract, and then the substitution is putting a negative 2 in for x. So take a look at this. I did negative 1 in here for x, very careful with the parentheses and the square. Again, the parentheses here, putting in the negative 1. I scoop that up, minus, now I'm going to do this again by putting in the negative 2. So 1/2 negative 2 quantity squared plus 1 over negative 2. So this is going to have some really nasty algebra in this assignment. The key to this is to be very careful. So let's go ahead and continue. Let's simplify this. So let's cover this up so you don't get overwhelmed. This is negative 1 squared. That's a positive 1, so 1 times 1/2 is 1/2. So this is negative times positive, that's just a negative 1. Kept that with parentheses minus. This next one, negative 2 quantity squared is 4, so 4 times 1 is 4, all over 2, minus, because it's a negative times a positive, that's negative 1/2. Again, please be very careful. Next, 1/2 minus 1, that would be a negative 1/2, minus sign. 4 over 2 minus 1/2. Got a common denominator, so that's 3/2. So negative 1/2 and a negative 3/2 is negative 4 over 2, which is negative 2. So that is the area underneath the curve above the x-axis from negative 2 to negative 1. Obviously, by having a negative answer, I have some of this shape underneath the x-axis. Now, for absolute value, it is actually a piecewise function. The absolute value of x is actually x when x is greater than or equal to 0, and it's the opposite of x whenever x is less than 0. That's actually the true definition of the absolute value of x. So now, when I am given that my function that I want to take the area underneath the curve up happens to be an absolute value, I need to use this definition of absolute value of x. So the first thing I'm going to do is I'm going to create a piecewise function, and I'm going to have to bring up this antiderivative into two paces. And so I'm going to substitute 2x minus 3 absolute value of it, just like I did here. And so it is equal to the 2x minus 3. Well, I come up here at first because I have to know what it is for x. So I put the 2x minus 3 greater than or equal to 0, and I solve for that x is greater than or equal to 3/2. So when x is greater than or equal to 3/2, it's 2x minus 3, or it is the opposite of this, the opposite of everything here when x is less than 3/2. I don't need to go through and resolve that again. My piecewise function is broken up at 3/2. I'm sorry, I realize you cannot see that in the video. So I'm going to break up my antiderivative from 0 to 3 to 0 to 3/2 and 3/2 to 3. So here, when x is less than 3/2, so that's going to be from 0 to 3/2, I'm going to take that and distribute the negative. So it happens to be 3 minus 2x dx plus the area of this piece here, because it's in pieces. It's a piecewise function. And so this is when x is greater than or equal to 3/2. So it's going to be from 3/2 up until 3. From 3/2 up until 3, I'm going to use this function 2x minus 3. So now I'm going to proceed as normal. So I'm going to take the antiderivative. 3 is 3x minus, for 2x is 2x squared all over 2, from 0 to 3/2, plus the other piece. So the antiderivative of 2x is 2x squared over 2, minus, for 3 it's 3x, from 3/2 to 3. So let's put in 3/2 for x, minus, so I notice that the 2's cancel out, so it's just 3/2 squared. I scoop that up because I know that the 0 is going to make all that go to 0. Here's this plus sign. Now I don't have 0 here, so I need to have 2 of these with subtraction in the middle. So first I'm going to put 3 in for x, but again these 2's are going to cancel, so it's really just 3 squared minus 3 times 3, parenthesis. Now I'm going to do this piece with 3/2. So again, those 2's cancel out. It's 3/2 squared minus 3 times 3/2. Again, it's a lot of algebra. 3 times 3 is 9 over 2, minus 3/2 is squared, so that's going to be 9/4. Have my parentheses and my plus sign. So I'm going to have a giant parenthesis. 3 squared is 9, minus 3 times 3 is 9. It's going to end up going to 0. Here's this minus sign. 3/2 quantity squared is 9/4, minus 3 times 3 is 9 over 2, 9/2. So I'm going to change this to a common denominator of 4, which means I multiply this by 2 over 2. So that's 18 minus 9 over 4. Plus, there's that 0, and then I have this minus sign. So I'm going to go ahead and do math on the inside. I need a common denominator of 4, which means I multiply this second fraction by 2 over 2. So that's 9 minus 18 over 4. So now let's go ahead and clean up this first one. That's 9/4. minus, that's negative 9 over 4, but negative times negative is my positive, so that's 9/4 plus 9/4 is 18/4, which simplifies to 9/2. Thank you.